Well, hello everyone, and Jonathan, thank you for that nice introduction, and I appreciate the opportunity to present in this format, a little different format, and we're all changing these days to the JPD for their online, I guess, educational format is the best way to say it. So what I was asked to talk about was how I integrate, I guess, the human touch into what I'd like to call the digital dental team. So share with you my workflow today and specifically some of the ceramics. Excuse me, I got a little bit of a sore throat today, so I apologize. How I incorporate these ceramics that I use, and maybe the ceramics I would recommend in this space. And it'll be a two-part presentation. I'll talk really about the aspects of this digital workflow, how I do it, and then the second part, which will be roughly about 40%, will be the actual human touch, what I do after it comes out of a machine. And so I'll let you know, Jonathan, when that break is as we go forward here. Many of you know my other passion, other than making teeth, is doing movies. Due to time today, I'm not going to show any movie, but if you're in Chicago next year at the Lab Day, I'll be showing the director's version of what I like to call Ceramists Never Die, because I still believe we need ceramists to help us, maybe at a little different type of workflow today. And I just wrote a script for this called The Dental Expendables. So hopefully start shooting that next summer. And those of you that like those, you can probably see them at some lecture that I'll do in the future. Many of you know I spent 22 years at UCLA. I had the best commute on earth between those two circles right there. And then I spent a couple years at UAB helping them start their program. But before I got too old and withered up into nothing, I decided to start my own little small teaching center in a beautiful place in the United States called Park City. Many of you skiers, or all of you skiers, I'm sure have heard of that. And it's a fun little place. I moved the weights into another room. But we have 12 stations for ceramists. I have a little operatory set up too, so we can treat a patient. And I like to teach dentists and ceramists in fun sort of team sorts of things. So you can find any information about that on my website if you're interested. Now, everything I'm going to talk about today, I actually test. If I talk about a bond strength, I've tested it. Or I talked about a flexural strength, I've tested it. I built two labs over the years, research labs, one at UCLA, where I put my own money into it, and one here at this facility here where I have about $250,000 of equipment for a couple of reasons. One, I really want to know the truth, number one, even though I realize it's in vitro research. But number two is I tend to trust less and less and less what I see published today and what I see advertised by manufacturers. So at least I want to verify potential claims. So I have Instron, I have a wear machine, I have a spectrophotometer, I have a thermocycler, all kinds of fun stuff, the ability to machine and the ability to print, three different printers, Sinter, Ean machines, things like that. But I don't own a Ferrari because you're looking at the Ferrari right here. All right. Just some more of my equipment so that I think I'm credible when I certainly talk about things. The second part I'm going to talk about after the digital dental team is how I finish restorations. I'm actually working on a book by this title right here called Ideal, Creating Ideal Surface Finish in Dental Restorations. And it'll have chapters on various different topics, all the way from how I put surface texture into wax before I press it, or a diagnostic wax up, or treatment wax up, I like to call it. Zirconia, I'll have chapters on zirconia, chapters on regular glass ceramics, feldspathic based glass ceramics, porcelains, things like that. Then higher strength glass ceramics like Emax, like Amber, like Vita's material, Suprinity, and several different clones on the market. And also on composites too, how I would finish a composite. And we'll have a chapter on how we do macro photography, how we do this type of close-up photography. I'll be doing that with one of my, probably the most talented resident that I ever had in my life, Diego. I actually call him Diego Baracus because he's going to be in that movie. It'll be a version of the A-Team and Stallone type movies, okay? All right, so you can watch for that. Now, as I start out, I think it's good that myself and all lecturers, educators, really at least share their bias, what they maybe do the most of and believe. So over the years, I've just adapted to doing Minimal preps. I believe in prepping an enamel, especially if I'm doing an adhesive feldspathic restoration. So over the years, I started in 1983. I've done a little over 10,000 feldspathic porcelain veneers, and one of the best reasons for that, it's beautiful, and the second best reason is it can be very conservative. And we now know from good literature, and I can tell you from my data too, that as long as we're mostly in enamel and the occlusion is reasonable, these things do phenomenal. Very, very low failure rate. So you're looking at 10 veneers there, and I mean these are extremely minimally prepped veneers. In fact, you're actually looking at the preps on the top slide. Okay. All right, just to show you another case, I actually do some work for some friends of mine, because it's fun to work with other people too, because I like doing actually ceramics the most. Doesn't pay as well as cutting holes in teeth. I did a case for Richard Young, one of his patients who happens to be, I believe she's an oral surgeon, had some old bonding and a couple of veneers she didn't like, so I think I made 10 veneers for this. And I ended up cementing it because she came out here on try-in, and Dr. Young was completely fine with that. So he is the prepper, I'm the cementer, and we made the veneers. So again, feldspathic porcelain, very, very thin, except on the centrals, obviously had a little bit more room to work with there, cutting off that old bonding. Okay, just a close-up view. All right, so contemporary monolithic ceramics is one piece of this pie that we're going to talk about at length. And I'd just kind of like to start maybe with a little history lesson. I don't know that that's necessarily so important, but clearly Vita was the initiator of all this and the market leader for the longest period of time with Vita blocks, Trilux, Forte, other types of things, and now came out with a Suprinity recently, all the way back to 1986, approximately 2006. Ivoclar came out with Empress CAD, and Empress CAD, different versions, different colors than you're all familiar with. Probably the most, well, not probably, the most popular glass ceramic by far on the market today, whether you press it or machine it, Empress, or Emax, excuse me, Emax or Emax CAD. All right, then a whole bunch of new things have come out in the last few years. Vita Suprinity, Amber Mill, GC Lisi Block, Tessera, and more and more and more. And and I've tried all of these. I'll share with you the three that I use today, and there's each of them have its own individual features. And then even more recently, we've seen the evolution of zirconia, specifically more translucent versions of zirconia that have higher amounts of yttria in them, which create then higher amounts of the cubic phase. Excellent materials too. Honestly, for me, it's not a veneer material. Maybe if I'm doing a bunch of crowns and I have to do one veneer, because we get such good results with those previous glass ceramics that I mentioned. But certainly wonderful materials for full crowns, especially since the translucency is improved and the strength isn't sacrificed too much. I will not have time to get into those materials because I've done a ton of research on that with my team at UCLA and a few people at UAB. And so the only thing I guess I would leave you with today would be is all of these materials are evolving into a gradient material, and not just gradient in color, a gradient in yttria, and thus a gradient in cubic phase, and that's potentially a very nice thing to have, because we can have the stronger stuff deeper in the restoration, which is a little bit more opaque, and the more translucent stuff more superficial or more enamel area in the restoration, assuming we nest it correctly, which is a whole other topic. So I today would strongly recommend one of the gradient materials. Ivoclar again being the first with this, with the material Prime and E-Prime, I like to call, or Prime Aesthetics, and there's several other players, Noritake in the marketplace. Jed Archibald, who I'll mention later, told me that in the last year there's been 4 or 5, 6 more players in the marketplace in this space. But some exciting things in material science. Okay, so why are we doing these types of things, and really what can they do? Now, as I show you this, okay, and why I've changed a lot over the years. Most of you know me as a veneer guy, and I'm maybe a no prep veneer guy at one point in time. You can clearly see the before and afters here, and these were very, very minimal preps. Okay, yes, I did put a light chamfer on, but 100% in enamel, just rounded the facial and sized the line angle. But what material is it is the key. Okay. I mean, to me, this almost has a feldspathic veneer effect. And as wonderful as feldspathic veneers are, I mean, if you lengthen a teeth 3-4 millimeters, you're running in a potential risk of fracture. And as hard as I try and control it, occasionally we have some. This happens to be a glass ceramic, a machine glass ceramic, monolithic, non-layered, just designed correctly, painted correctly, fired correctly. There's some other aspects to that to get this type of result. And then, for the longest time, I was a little bit, let's say, less excited about lithium disilicate, but the materials have improved, the color gradients have improved in the material, and then techniques also to develop translucency and how we fire it. So this is monolithic Emax. And honestly, to me, I don't think I could do that much better with feldspathic porcelain. So this is clearly probably my main material today. Clearly, there's other materials out there. I like the Empress material. I'll still show you that. Empress Multi is an excellent material. And then obviously several competitors on the market. Amber Mill, I use Amber Mill occasionally too. But this is still my primary material. All right, so what do I mean by the digital dental teen? It has several components, okay? It's a team of things. One, obviously, we have to have a dentist. We've got to have the technology or machines. We have to have the right materials. But I think we know, or we all know, or we've all seen anyway, what comes out of the machine is far from a finished result. So we still need that person to touch it up, the enamelizer, I like to call, maybe little pieces of enamel, the dental sculptor, the dental painter, let's say something like that. And so that still is a large aspect of this process. Okay, so you're looking at the materials that I like. I started with Vita. Nothing wrong with the Vita materials. They're excellent materials. But more recently, because of the lithium disilicate, the higher strength, and honestly, we did 3,000 onlays at UCLA, and to my knowledge, one of them broke over the years, and that was with the graduate students. So this material has been very successful clinically. There's a bunch of papers published on it, on its clinical success with a phenomenally low failure rate, less than we would see even for a PFM, let's say. Okay. And then the dentist. Obviously, the dentist is the driver, the architect of this picture. The interesting thing for the dentist is you're basically going to do the same two things as a dentist. You're going to prep. Now, your preps are going to change a little bit. There's a little different type of prep we need to do, especially if we're going to machine restorations. Pressing, no. We can get away with certain things, but we want to use these digital processes as much as possible. And then your cementation techniques would be whatever you would normally do for adhesive restorations. And again, this is the reason why. So these two files were machined, these two restorations were machined from the exact same file. They are monolithic, translucent zirconia with no porcelain. So you can get understanding how you can get this kind of aesthetics when you understand how to fire. And we've come up with different firing techniques, different lengths of time in the heat zone, different temperatures that give us a little bit better translucency. And we published on all this. It also doesn't affect the strength if you change the firing temperature a little bit anyway. And then all we did here was a little bit of internal colorization, a pre-sintering of these materials. Okay, so really excellent result. And then this case that I showed you just a second ago that we'll actually finish with, I'll show you the final and everything pictures. This is typically how I work today. I work with Jet Archibald. I'll scan, send in the files. I've done some sort of aesthetic mock-up or aesthetic prototype, I like to call it. I've scanned that, and then he's going to machine these for me, and I ask him to maybe be 3 to 5% slightly oversized. Now, people ask me all the time, well, can't you just design the surface texture in the file? Sure. Okay, we can do that. But if we're doing minimalistic facial veneers, where are we going to sprue that? I mean, we don't have a lingual to attach to because we didn't prep the lingual, okay? And I don't want to over-prep teeth just to use the machine. So what we end up doing is having to put a sprue in the middle of the facial, and actually quite big, because we're machining it very thin, so we don't want to have any slight flexure that might cause chipping or breaking. So the surface texture, there's not much point in putting it in the computer, but then we need to be able to finish it on the back end here. And that is that case you saw earlier, 100% monolithic. There is no porcelain there. Okay, another case, same basic thing. Okay, different material. All right. So we can get a great result with different materials. There's 2 or 3 on the market that I think are pretty good. You already know what I like, and I think the market leader. Not here to sell anybody's product, okay? Just to inform. And that's typically how I design it machined. A little bit over contoured, not too much surface texture, the basic shape, so I can then finish it down. Now, one of the things that became very interesting to me, I mean, if we're going to move into this monolithic space with our newer materials, whether it's a glass or whether it's a zirconia, how easy is it to actually match a shade and work in, I guess, thinner spaces? This had a little extra space because it was an old crown that I cut off, but this is a try-in of a monolithic zirconia, a higher translucent zirconia. It's happened to be Prime Aesthetics. That's the try-in, and here it is finished. Okay, still got a little cement up there. My bad. Of course, clean that up at some point. Now, my point being is that if you understand the materials, understand how to internally color, we have a grading of translucency in the material. I touch up a little bit on the color on the external. What happens is you get something that's pretty good. Now, does that match a layering effect? It's getting close, okay. But the benefit is that it's so close that usually an observer is not going to be able to see this at conversational distance. So, if you don't have that super high aesthetic patient that multiple different lights, discos, things like that, that maybe is on camera, this is an excellent alternative because I'm not worried about this breaking. Now, maybe the tooth will break, but this won't chip or break. I just haven't experienced that. All right, so let's get into this actual workflow that I call the digital dental team. Let's start with something like this. I think we're all familiar with our analog workflow, right? The dentist does analog everything, technician does analog everything, and the dentist then on the end, after they get the restoration, does analog everything. And there's still, a fair percentage of people that do that around the world, or even part of their daily practice. Then, 30 some odd years ago, came on the market the CEREC and other systems to augment that workflow. And this is, a very popular workflow today, where the dentist basically and the technology, all the initial stuff that goes directly to the patient. There's no technician in between. There's no laboratory in between, and they get cemented. CEREC being the first on the market, and then a few others that have come out. But I think this is a super interesting topic in one aspect, okay? Because I think these companies have missed a very large potential market that I believe is a better market, and most people would tend to gravitate toward this. But from a business model, it's sort of interesting that after roughly 30 some odd years, 40 some odd years, there's only been about 15% market penetration with these systems in Western countries, let's say, in the United States too. And it's you. Let's go back 40 years. If you were the person that came up with this idea. You walked into a Fortune 500 company that you work for, and you were in the product development. You said, "Hey, I got an idea for a product, and this is." You explain your product. Let's go to what it's going to do. The suits, the business people, the accountants, the bean counters are going to go, "Great. Okay, show me what the return on investment is." And I can tell you, knowing enough business people in the business world, me not the best business person, okay, that they would tell you that after just a few years, you would want to have about 10% market penetration. In other words, people using the technology. By 40 years, it should be relatively 100%. And at 40 years, we only see 15, maybe a little bit more market penetration in that. So it's a tough market. The machine, the products, the disposables are probably the bigger aspect of the market. And you see, and I know a lot of people that have these things. We had one at UCLA, and I love the concept. But what comes out of the machine isn't finished. So it's wonderful for a posterior tooth, maybe a single tooth, maybe even an implant abutment or something like that, or provisionals. But for 6, 8, 10 anterior teeth, it has to be physically altered, physically touched up. And most dentists don't have the time to do that. That takes a little bit of time to be able to do that. And I can tell you probably at least 20, 30 minutes a tooth. So 6, 8, 10 teeth, you've got 4 or 5 hours of time and finishing and touching up, painting and glazing, which just doesn't work in a daily practice. And this is, I think, the kind of the dirty secret that people don't talk about that much, these aspects of that. All right. And so this is kind of, sorry about the font's a little bit off over there. I see now. Okay, should have resized this to 16 by 9 from 3 to 1. I would like to propose a model, and Lee Culp and I wrote this paper a long time ago. I don't know, when was it? It's been 15 years, I guess, or something like that. And I've wrote a couple of papers since then on this. Has it been? Yeah, 15 years, I think. And we called this the Digital Dental Team, where, yeah, we want to take advantage of the scanners, the intraoral scanners. We'd love to be able to do it in the same day if possible, but the in-between goes to a lab that's close by. So the concept is, dentists, you can't have $500,000 machines and update them every 2 or 3 years. Bigger labs can, or at least medium-sized labs can roll the technology because they work with maybe multiple dentists. So you've designed the case, you've got your prototype ready to go, you got the design in the computer, you prep and you upload the data to the lab. And then they can print a model, they can machine the restorations, they can stain and glaze, assuming it's a simple case, and potentially deliver it in the same day. But certainly in a much shortened period of time over analog, okay? And give the patient a much better result. That increases the productivity of everybody. So that's what I would like to propose is our true model in doing this in the future. And so let's talk about some of the machines, okay? There's some wonderful, excuse me everybody, again a little bit of a sore throat right there. There's wonderful machines out on the market, and I've had several. I'd like to share with you what I have. I always like to give you at least 2 or 3 products. So I'm not married to one or the other, okay, and tell you what works. So I have a Medit and I have a Trio scanner. They are both great scanners. And people ask me, well, which one do I like better? I can tell you my laboratory, Jed, he thinks it's a little easier to work with the Medit software. And if you look at the literature, it actually says the Trios is a little bit more accurate scanner. So we did a little test. We send a couple of things and see how they fit to a model. We could, and with microscope, and I got a 20-power microscope over here, we could not see the difference in fit between the 2 different systems. Now maybe the pure science of it, with whatever measuring device they used, yes, it might be a little bit more accurate. So this is a little bit easier software to use, all right? So, and this is less expensive, but would you necessarily buy that one? My recommendation is it depends on how many you're doing in a day. The Trio scans about 50% faster than this, okay? And so, you're talking about 2, 3, 4 minutes over here, maybe a little more if you're slow like me, maybe a minute over here. If you're doing 6, 8, 10, 12 patients in a day, that time's going to start to add up, and it's going to make sense then to spend the little extra. This used to be double the cost, but it's come down. It's maybe 25% more cost than that. So that would be my deciding factor based on exactly my application. And then another thing that I'm finding, and I think many of you know this, as you work in this space, whatever space, a large aspect of products today or equipment today is who your rep is and who the company is. I mean, does the company stand behind their work? Do they have good customer service? Do you have a good rapport? I've worked with several companies in the past that I don't work with today because I don't know who I'm talking to from day to day. And so I need to feel a little bit of stability with a company, especially if I'm putting a fair amount of money into a big purchase. So those are the things that I think about anyway when I'm going to buy. I have all these printers. I have a couple of machines. Now I guess maybe I would like to make one recommendation. If you've got a smaller office or a smaller lab, I would seriously look at a machine that'll machine wet and dry, because it's too expensive to have 2 different machines, and it's also a space problem. So this is the one. If you're in that space, I mean, they all mill. There's not all of them, but several of them mill very well today, and I'm happy with what I see. The Roland does a good job, but when I was at UCLA, I had to have the 2 Rolands. So a smaller office, this is a little bit better use for me, and I haven't had any problem going back and forth from one to the other. Okay, so typically what I would do I would machine one day wet and machine one day dry, so I'm not constantly cleaning things. Several wonderful printers on the market. The printers have gotten a lot better. Now I'd like to say a little bit about the digital space. I was very resistant about the digital space up until a couple of 3 years ago to really adapt to it, okay? Because I was not happy with what I saw with the prints. The prints, and you still see this with some lower quality printers today, or lower quality settings in the printer when somebody prints it, is that you see all these little waves on the surface. the print waves. That's the size of of each layer, I guess, is the way to say that. And most labs are setting these things to 100 microns. Well, for me, I'm doing anterior teeth. I want to see the microtexture. I need to see, if I'm doing one central next to the other central, I need to see the texture in the die. And up until recently, that was not possible. Okay, I'm working with a guy I'll show you in just a second. And if you haven't bought a printer yet, I would wait till next year, because there is a printer that's going to print an 8 and 12K, coming from a company that just entered the dental space called Frozen, and I have no attachment to them. Okay, Phrozen. They're in the industrial space. They're in the commercial space, for retail, things like that, for small printers, but they've just entered the dental space, and I want to show you what we're doing with this. We're doing some tests with this. Let me introduce you to Jed Archibald. For about 20 years, he did all of the specimens for clinicians' reports, all the stuff that you might have read in Gordon and Rella's newsletter. Really, he came especially in machined areas, any digital areas. Now, this is the guy. And I love to promote this guy because he is the most knowledgeable person, in my mind, on earth on 3D printing and solving those situations that can come up. And anyway, he's got like 16 or 17 different printers in his lab. And so if you're having any issue, you have any questions, you need any help or something like that, he's happy to answer questions. And he's kind of set all of my stuff up here. You can contact him, and he's the guy that's doing all of my digital for me today. Even though I've got all the stuff here, he'll design it and send it, or he'll design it and print it, or machine it for me. And one of the things that we've been working on is trying to get model work very similar to what Willie Geller has done with his model work with analog processes. So he's been working with a company called Shara, and they came out with a product called Shara Easy Model. It's phenomenal. You can reach to Jed and have him share with you where to get that. It's a German company, but they sell the software, and it works with anybody's printer as long as you do the settings right. So that's how we're doing our prints. Now, the other thing we're working on, again, is working with this Frozen printer to get better accuracy. So these are two different resins with the same new Frozen printer that we were playing with that you will see on the market very soon. I want you to look at the detail on this resin. Yeah, it's pretty clean. We don't see a lot of those print lines, but I've never liked the overly glossy look of a lot of the resins on the market. So Jed and I have been working on a formula that we're going to just give to some company here soon, and it's basically done mostly by Jed because he's the genius, but with my input and my help, is a resin that's non-reflective like stone. So we're trying to go for a quality of a Type 4 dental stone. And what you'll see with this is with this printer and this stone that we're getting under 30 micron accuracy in the X, Y, and Z planes. So that's what made me very excited about fully moving in the digital space. Up until, let's say, 2 years ago, or a little less than 2 years ago, like 98% of what I did was analog relative to my model work. Then yes, I would scan the model work. I have not made a physical impression in probably 18 months because of this, because of the scanners. The scanners were never the issue. It was just the output. So I'm getting some amazing model work. In fact, the only time I make an impression is if I am duplicating a die or making a refractory die or something like that. So that's the interesting aspect of the technology, and there's multiple things that we can plug into that space, okay? So let's talk about what the dentist would do, or how my workflow as a dentist today. And we've all familiar with the term diagnostic wax up. I've never liked that term because what are we diagnosing? We're designing something. So you might hear me say design wax it. I'm basically designing the shape that I want to do. And so how I incorporate digital today in this, theoretically you could do all of this digitally, but again, the same thing, that whether I print or machine, and actually you can't print wax, okay, it's got to have a little resin in it, but we can machine a quality wax today. But same thing, there's no point in putting on surface texture, because I had to sprue it here on the facial because these are veneers, let's say, all right? Now, there was been so many different materials on the market that contained resin, and most labs like to machine the wax resin mixture. The reason being, if you machine a pure wax, the wax would melt and gum up your machine. Now, this is an idea you might have heard of, but it actually came from Jed. This was Jed's idea several years ago, and this is how we do this today. We take this wax, and we like the Purity wax from Harvest. Why? Because it's the same color as Renfert wax, so I can add or take away if I want to analog techniques. But the other thing, and this is Jed's idea, what we do is we put this in the freezer. So we keep our wax in the freezer. So once we've designed, we've sent the files to the cam, we're ready to push start. We pull the block or the puck, I always love that term, puck, like hockey puck, from the freezer, and we load it into the machine and push start. Typically you'll have about 3-4 hours of machining before the wax starts to be problematic and get too soft. So that's how we design. Jed gets it to this point for me. Let me go back one. Jed gets it to this point, and then I take it from there, and I go ahead and put in any surface texture I want, little form, little beads of wax. So I've got 5, 6, 7, 10 minutes a tooth maybe versus a half hour a tooth. So it saved me roughly 2/3 of the time by doing it by this process. Now, one of the things that I still like to do when I'm doing my design wax up, I like to put a little bit of surface texture in, lobes, even tertiary anatomy, what we think of as tertiary anatomy. That'll change in a few minutes for you. The reason being is because I'm going to put that in my temporary or prototype. If I want to put surface texture in like you see there, I want the patient to see and feel what I want to do. So if I'm delivering the restorations, he or she doesn't say to me, "Doc, what are these little rough edges and stuff like that?" Which if you put surface texture in, trust me, it will happen if you didn't have it in your prototype. So the long involved discussion there was I could not find any decent instruments to do microtexture and wax. So I've designed my own set of waxing instruments. It'll be ready at the Chicago Midwinter. I am taking nothing for it. By the way, anything that I tell you today, any material that I might recommend, I've never taken a back-end deal. I've been offered several back-end deals, several percentages if people buy things, and I've never taken it and never will. Suppose if I'm destitute on the street maybe. So anyway, I went to these guys, and they're making these instruments for me, and I told them I want them to get them on the market most cost effectively. This whole set I believe is going to sell for close to $100. If I bought something like that from a competing company, I'd probably pay $300 or $400 for it. So you can look to them after the first of the year. So I can do this. So I typically machine a little facing, adapt it to the model, and I put my surface texture in, and this might take me, an hour versus 3 or 4 hours or something like that in the old days. All right, then I like to do next, so that gives me my basic shapes that I want to go to. The initial design I might have done in the computer. In fact, I would have done in the computer, and then the final design is in wax. And then I like to do what I call the bonded functional aesthetic prototype. English was a challenge for me my whole life. Okay, I wrote a few articles on this over the years, more than this, but these are the two main ones. And I like to call it aesthetic prototype because really that's what we're doing. If you look up the word prototype, it says working functional model, and obviously we want it aesthetic, and many times we want it functional, and if we want it functional, we got to bond it a little bit. So I go into the technique. So that's the first step in the digital process, marrying the digital and the analog, and then I have Jed print me some sort of tray. So the pre-op was scanned, the design was done on the computer based on what my analysis was, the wax-ups were machined, and then I touched them up, and then he sends me the model, or sends me this tray with about 3 millimeters of space. Now I want you to notice as I'm designing this tray, a lot of people like to scallop trays. Great, because they can clean up around the margin. The problem is I find my margins aren't as well adapted as I would like. So I actually asked Jed, when I used to do it physically, analog, to create 3 to 4 extra millimeters beyond the free gingival margin. You'll see why in a second here. All right, then I'm going to do a typical analog process at this point. I use a clear polyvinyl siloxane. I adapt it to the model. There's only typically one viscosity, so you got to blow pretty hard. Some of the techniques that have been taught in the mouth. A trick I learned from Gordon Christensen, 30 some odd years ago, to after you inject your material, blow it toward the tooth to hopefully push out any air or any bubbles that might be there. All right, then you're going to put some of the material in the tray. and then seat the tray. Now, typically what I don't do is I don't bond the material to the tray. So there's actually a little bit of Vaseline in there. So when I cure in the mouth, I can separate the tray and then separate the matrix. So that they're two separate pieces. And yes, you do need to put some sort of little seating notch so you then know two come together. So when you seat it, okay, you use whatever material. I love flowable composites, and I had a special composite made. Bisco made it for me. They stopped selling it because, or stopped making it during COVID because a lot of things stopped. But there are several companies that make a functional structural, electrical structural composite that means that you can put it on the occlusal surface. Not as good as a regular composite, but certainly great for this technique. 3M makes one, Kerr makes one, Voico is probably my favorite one today. Why? Because best aesthetics. Twice as expensive as everybody. All right, so you inject whatever material that you like in here, and we talked about this years ago, and you see a lot more people injecting, okay, where they're cutting little holes in here. Did that too. You can do that. Number of did that since a long time ago, but I find that I'd rather do them all at once. And if I design this correctly and the matrix fits well, I can do them all at once, and there's not that much finishing, okay, and I can still separate them if I want to. Okay, so when you seat them, this is the reason for the extra material up here. So what I'm typically going to do, these two oval shapes right here, once the material, right before I start to cure it, I'm going to push on there. I'm going to push toward the gingiva. You'll see a video in just a second here so that it daps really well interproximal. So here we've seated it. We've waited a few seconds. All right. Then I'm going to take and I'm going to push toward the tissue. Only touching the tissue area. I'm not pushing over the teeth up here. What that does is that'll force the material, that'll seat it real well, make sure it's seated, then we go ahead and cure. So I hold it tight while my assistant goes around and cures. Now you can see I've been doing this for a long time. That's a Optilux 501 from 20 years ago. So I've been doing this for over 20 years. Okay, and I made the video then and it's still good today, so why make a new video? Okay, trust me, it's a lot of work. Those of you that do it, you know it. All right, so after you take out the matrix, look at, assuming you did wax up, assuming it fit okay, all the things that you know you have to do, look at how thin this is. There's virtually 50 microns of flash. Look at the detail here. It's amazing detail on the teeth. All I got to do is flick this stuff off. It comes off very easy if it's thin. It fractures right where it's paper thin there at the margin. And then, yeah, there's a little bit of touch-up. And if I want to, I can use a little separating blade, composite separating blade to separate the teeth. But, boy, this is fast if it's done correct. Now, if you don't want to use a composite, light cured material. I've tried several different bisacryls or chemical cure materials. Like I said, I will try and give you 2 or 3 materials that work. I use a lot of different things, but I have not found a material close to this in aesthetics. From Voico. They have a material called Structure 3, Structure Premium. Honestly, they look the same to me. This is supposed to be a little finer grain, a little better polish, but I personally can't see the difference, all right? So I think that if you stuck with this stuff is almost as nice as a light cured flowable composite. So typical before, this is the temper I made before I touched it up. So right after seating, right after removing the matrix, you can see there was almost no flash here. A couple little things here, a flash, a couple little things here that I'm going to have to adjust and polish, okay? So that would be the material I would recommend. So let's talk about digital veneer preparation and what's similar and what's different for maybe our more analog thought processes for minimalistic porcelain veneers. What I can tell you right off the top, you know, I've done a fair amount of no prep veneers over the years. I rarely do it today. It'd have to be it'd have to be a perfect case and perfect patient, and you know, there's nothing ever perfect, okay? But I can tell you that machining veneers does not lend itself to a no prep veneer. Is it theoretically possible? Sure, but the odds of chipping the margins, understanding where to fit, the scanners just don't like it if they can't see a margin. The labs don't like it if they can't see where to finish to, and I happen to be both the lab and the dentist. You can get away with a mini prep though, and I'll define what a mini prep is, and then obviously the rest of the preparation stays the same. Part 3, okay, not part 4. The rest of the preparation is going to be based on your aesthetic outcome and your material requirements, okay? And then you also need to understand what your machine will and won't do. So we'll talk about that. Okay, now working with scanners and having several scanners over the year, and the two I use now I already told you about, I can absolutely tell you, and the model work too, that to make the model work, to make the prints, to separate the dies, the scanners have to see the margin. If you finish a margin in a contact area, it's the same problem, I guess, with analog. I can't separate the dies very easily. I can't without chipping one of them. It's the same thing here. It's very difficult to get the proper fit, proper contour design without a little bit of separation. So you either have to stay labial to the contact or maybe slightly open the contact a little bit, or you're going to run into problems. Everywhere else, at the margins, the incised ledge, you want to see a clean finish line. No different, really, I suppose, than analog processes. Now, one of the big things that come up when we're dealing with a concept of machined veneers is one of the complaints, and I was one of the biggest complainers in the past, and I got in trouble for my big mouth, I still do today, was concerned about chipping and poor margins, that the margins were just like socks on a rooster, all the funny adjectives we like to use. All right, well, Jed and I over the years, and working with Lee Culp way back, and God, when was that? Somewhere in the 2008, 2009, somewhere, so 15, 16, 17 years ago, like I said, we basically came up with the idea that we just can't machine ceramics to a margin less than about 45 degrees, and ideally 90 degrees. So when you start getting under 45 degrees in your margin with a glass ceramic, maybe not zirconia, but with a glass ceramic, that margin's highly likely to chip. So the simple solution to that was, let's just over design the margin so you can see this positive lip. So the exit angle of the machining is actually 90 degrees. So the fit can be excellent, assuming it, you all do other things right, but we don't have an issue with chipping. But we got a big extra bulk at the margin, which means this is no longer a chairside technique, right? You have to do something else. So what we do is we actually finish it with some sort of rubber wheel. Specifically, I like zirconia wheels on glass ceramics, so we can rubber wheel it down. So let's look at a close-up of essentially what I'm talking about. So this would be a fairly minimalistic prep, 3 to 5 tenths of a millimeter with a margin design that's clearly less than 45 degrees when you figure what's got to happen here, right? That basically contour right there. So maybe right at 45 degrees. The reality, though, is that is likely to chip. We're likely to lose that little piece of two structure up there. So this is basically a schematic of how we would design it today. So this is obviously the internal contact angle of the veneer. The external angle right here, which will give us this little bulbous area here, we make that at 90 degrees. Again, then we're going to have to finish that down. So Jed's designed different amounts in the software, and he can certainly help your technician with it. And he just asked me, Ed, do you want a tenth of a millimeter extra? Do you want 0.12? Do you want quarter of a millimeter extra? Now, typically for me, because I don't mind finishing it down, I'm going to be over designed in one of these two spaces, roughly 0.2 or 2.5 millimeters over design. Again, so this is what it would look like. It fits very well if it's done correctly. We've got this very positive angle that's clearly over contoured, and I like these zirconia dialite knife edge rubber wheels, I guess, impregnated rubber wheels to finish down the margins. They do a great job. You want to be careful that you don't overdo it and damage your die or something like that. But that does a very good job. Now, the other trick to get the veneers to fit a little bit better, another complaint is that there's too much space inside, too much cement space, which can create its own set of problems, is we typically design it a little to fit a little bit tighter. So we take out some of the cement space. So with a very small cement space, that is going to usually mean that it's going to fit a little bit tight. No problem for me and in our workflow, because I'm just going to put a little bit of marking material. I like the Annexdent material. The name escapes me right now, but their marking material. Liquimark is a material you can get from Shine. Just some sort of very thin red paste, and then we just adjust the inside to get it to fit. And that works very well. So relative to the design of the preparation for the veneer preparation, as I said earlier, we need to have at least some sort of finish line. So what I found is I want to be in about the 3/10 of a millimeter finish line. If I'm doing feldspathic, I could probably go a little bit less than that. But for machine glass, I want 3/10. And like I said, I would add a little bit in the computer, and we'll finish that back down. Now, the concept of shade change for a machine veneer is really the same as a feldspathic veneer. What I found, to change a shade effectively and still have a believable looking tooth, you need roughly 2/10 of a millimeter for each shade change. What I mean by that is to go from A1 to A0, 2/10 thickness for your veneer. To go to A2 to A0, 4/10. A3, 6/10, on and on and on. For the new Vita Shade Guide, or relatively new Vita Shade Guide, the 3D Master Linear Guide, the second version of it, same concept almost, very similar. 1M1 to 0M1, 2/10. 2M1 to 0M1, 4/10. Now, a little caveat in there. You can't machine that thin, or you can't make veneers that thin. So typically, I won't make a veneer thinner than 3/10. When we machine it, though, it's about 4 or 5/10. So to machine, you don't want to be too much thinner, maybe 4, maybe 5/10. Probably 5/10 is safer. And then I'm going to finish it by putting surface texture in, bring it back just a little bit. That's not hard for me to do. Same thing with feldspathic veneers. I don't want to go too much thinner than 3/10. Actually, 3/10 would probably be a minimum. Why? It's just too difficult to manipulate, too easy to fracture. I had a beautiful case 2 weeks ago on a dentist friend of mine. I'm trying the veneers in. They're all fitting, about ready to go to cement, and one of them was about 2/10. It popped right at the incisal edge. I wanted to cry. I wanted to scream. Of course, I didn't. Later, I did. Okay. All right. So, so the basic machining. My thought process is, if I'm going A1 to A0, 3/10, because that extra tenth for making it or machining it. A2 to A0, 5/10. A3 to A0, 7/10. 1M1 to 0M1, 3/10. 2M1 to 0M1, 5/10, okay, with at least 0.3 at the margin. You can go a little bit more at the incisal edge. Typically, I do at the incisal edge. Why? Because I want to increase the translucency a little bit. So if I have 0.5 thickness in the middle third of the tooth, I'm going to allow probably 2/10 more, roughly 7/10 at the incisal edge, just to get a little better depth of translucency. Makes sense. All right. And that's pretty much all I do. All right, just to give you a couple of different cases to explain what I'm talking about, this tooth is about a shade and a half darker than tooth number 8, tooth number 9. So I've prepped axially another 3/10 of a millimeter on number 9 to give my self space for color change, for the difference in color change. And if you're not going to layer, it's a little more difficult to do color change than it is with monolithic. From an incisal view, a different case here. This is about a shade and a half darker than this tooth right here, thus the deeper axial preparation to account for that difference in color. And here's the finished veneers. I just did 3 on her and bleached her teeth. Yes, I recommended more veneers, and I would have loved to brighten the color a little bit, but when I told her that multiples of thousands of dollars I charge after she got back from the coronary, we just did 3 teeth here. All right, that's the facial zone. What about the incisal zone? There's several concepts been talked about over the years, and each different rationales given for the different types of incisal preparation. We go back to the early 80s, so-called window preparation. I've never liked this because I always like to have a little bit of ceramic extend beyond my preparation so I can play around with incisal effects, translucency, things like that. Then I think it was Mark Friedman, no, excuse me, not Mark Friedman, but he was one of the bigger proponents of this, excuse me. Came up with Horn and Calamia came up with this, I believe around 1983. The idea is to wrap over the incisal edge, and most people do this today still. And one of the reasons, well, I asked John Calamia, I was at NYU a few years ago. I said, John, why do you do that? And I think he said to me something along the lines of, well, the initial idea, we didn't know if these were going to work. I mean, how well they were going to stay on and holding temporaries on. You know, this was just for macromechanical retention of the temporary and ultimately the veneer. And, you know, if you ask anybody or look at the literature, if we are staying intra-enamel, we just don't have problems with veneers falling off. Temporaries maybe with this design. And John would have said the same thing. So then more recently, this design, and I've been doing this design since 1988 when I started making my veneers, just because it was simpler. Yes, this is harder to keep temporaries on, absolutely, okay? But if you're into enamel, it does not affect the success or failure of the veneer. In fact, there's a few papers out there that talk about different incisal designs, these three basically right here, and you don't see a big difference, almost a non-significant difference in success or failure of the veneers, with one exception. The more you wrap over the lingual, the more coverage of the lingual, the higher the failure rate goes up, and it just makes sense. You got less tooth structure, more feldspathic. The feldspathic glass is going to absorb more stress, but also the geometry. If you start wrapping around things, you create interesting stress fields and different geometries versus just a straight facial veneer. So this is my favorite today. But the question is, can you do it with a machine? Machines do not like this. They do not like the incisal window preparation. Now the question becomes, do they like this or do they like that? So I put a big question mark there just to zoom in closer so you can see what I'm talking about. I would never do this today for analog or digital. The only time I might do the one in the middle is if I have a lingual erosion and I want to cover that up. But we're going to talk about this in just a second, this incisal area right here. Otherwise, I'm going to do something on the right. All right, let me explain why. Okay, the fundamental reason with digital is this: when you machine up in the incisal edge, whether it's a veneer on the left or a crown on the right, the burr's got to get there. And it's got to be able to navigate that space left and right so it machines enough so it seats. If you have too narrow of an area, which this was, okay, what the CAD system, the design system, is going to do, it's going to create what's called an offset. Offset meaning it just offsets here, takes some extra stuff out, whatever else it needs to take out to make sure this seats. Now we've lost all this space. This weakens the veneer if it's really thin here. It also maybe affects the color, so that is not the great way to go. Now we're going to talk about numbers in just a second. Let me back up for a second. You can see a different file design here where if we just have an incisal shoulder, and this was as machined. And you can see how well that fit. We got an excellent space on the inside. There's nothing wrong there. That's well under 100 microns, which according to the literature is fine. Anything up to probably 100 microns for the cement space, 40 to 100. Excuse me, excellent fit down there and no gap up in here. All right, so we've looked at different burrs. Now, I know a lot of people in the lab space because I do my own lab work too. Most laboratory technicians will tell you about burrs. Yeah, you can get a burr, you can get a needle point burr, you can get a little teeny tiny burr, 0.3 of a millimeter. All right, the problem is, just like we have in dentistry, these needle points are the microscopic burrs. You lose the diamond on the tip with really in a couple of passes. So they never want to use anything less than 0.6 millimeters. So that's the typical burr they'll finish with, is the 0.6 burr, and up in the incisal edge, you know, it has to get there, and so you have to think about that in your design of your preparation. And so what I'm talking about here is that this space right here, whenever you have a shoulder, especially if you're going to cover over the lingual, you basically need to think double the thickness of the burr. So my shoulder, I'm looking to make a shoulder, whether I wrap or don't wrap, at 1.2 millimeters. 1.2 from here to here, especially if I wrap, so that burr can get up inside there that I showed earlier. All right, last zone we need to talk about, what are we going to do interproximally? This is not very different than concepts you would do for an analog or regular feldspathic porcelain veneer. You got two thought processes really, okay? Do you stay close to the contact facially, all right? Or do you go all the way through in the lingual? The worst thing you can do is end up in the middle. If I'm not, option one, if I am not going to widen the teeth, the basic width of the tooth is fine, you are just doing color and maybe a little shape change or something like that without changing the width, I prep up to just short of the contact. And I want to make sure that the computer can see these margins. I'll scan it real quick. If the computer can't see these margins, differentiate these margins, and I'll go through with a little diamond strip for just to take off maybe 100 microns or something like that. If, however, you need to close a space, So we're going to close this space, maybe one or both teeth right here. We're going to take our finish line to the lingual transitional line angle and slightly subgingival. I'm going to close it more with this tooth right here, the canine. I'm going to go a little bit more subgingival so I can get a smooth contour coming subgingival into that space. That's what I was talking about, those right there. From an incisal view, incisal view is coming up. Sorry, I'm getting Alzheimer's disease as I get older here. God, I used to have a good memory. So let's assume this is the contact, this oval shape area is the contact. If I'm not widening the tooth, I go up to just short of the contact area, maybe 100 microns away. Again, a quick scan. Look at your scan, see if you can see it on the computer. If, however, we need to close a space, so the contact's in the same spot, we need to move that finish line to the lingual transitional line angle so we can effectively start from the line angle, sweep into the interproximal space, and close that space off effectively. And then typically I'm going to do a light chamfer, maybe 1 millimeter subgingival, so I can have a smooth contour and not have a ledge. This is the slide I thought was coming up next. So this is what I'm talking about here, is that this goes to the lingual transition line angle right there. Got my camera in front of my computer here, so it looks like I'm looking at you. All right, so that we can bring from the lingual transitional line angle here, we can step out effectively. I can design it so it's a 90-degree exit angle. We can effectively close that space. Over here, we're going to be a little bit facial to the contact, and I can still develop a little bit of contact in the material there. People have called that the slice preparation. All right, then typically what I'm going to do, I'll scan real fast, and I try and get my workflow where Jed's available, hopefully, that I can upload the file real quick, and before I do the final scan, I got the cord in there ready to go, and he just takes a look at it. He tells me what he sees and what is problematic. He's already got the scan in there of the prototype that I've made, so a physical scan of the prototype, and then he'll just overlap that scan. Now, one of the things he loves to do, and boy, I learned something about this, we get so enamored with that view that looks like real teeth. He says that can be very misleading. He says what the computer actually does is this. So he goes into the stone view. So always take a look in the stone view, and you saw some of those areas we couldn't see the margin. All right. So I had to go back and touch this up a little bit. So we touch it up a little bit. Again, show him the scan again, and then so we don't be too redundant, let me grab this. What he does is then he's going to put on the scan of my prototype, and then we make it more or less translucent. He can look through this, and we can see if we've got any space issues. He can measure. There's measuring programs to look inside. It'll tell you the thickness. Incredible what can be done with this today. Now, the other wonderful benefit of digital over analog, and I'm guessing mostly prosthodontists are watching this, we know what an incredible skill set and how long it takes to develop the skill set to be able to impression multiple teeth. And that's been always one of the biggest challenges to impression 14 teeth, all right? And we've all had to do that, and we've had to do it multiple times. And in analog days, I was sort of anal. I learned from Jack Preston. Some of you still know that name. I would take, and he taught me, I took 4 impressions. Now imagine the time involved with that, and also the trauma to the patient packing cord 4 times. You don't have to do any of that now. You could prep one tooth and scan, then you stitch the other tooth in it and the other tooth in it. Or you can do all 14 teeth at once. If you miss 2 or 3, you just pack cord in one of them, or whatever you've missed, and add that to the file. Once I finally got that into my subconscious, that benefit, and I got over my ego about being able to get 14 teeth in an impression, life just got so much easier. So those of you that are maybe resisting this a little bit, I would really spend a little time and talk with Jed first, because obviously I'm guessing, it's a guess, that the reason why you haven't changed isn't just because of the technology of the scanner, it's because you haven't liked what the prints you've seen. And trust me, that problem is solved. All right, then the rest of it's kind of the same. However you choose to take a shade. I take a shade with 3 shade guides. I use a Y-Bal shade card. You can use the one from Sascha Hein. It's called the E-Lab shade card. That works too, or gray card, excuse me. And then I measure color in Photoshop, because I got a whole little system. You can find my article, or 2 articles on it on the website. Now, I'll just give you another little pearl, and I'm sorry to seem to push a product here. I've hated all of the cord packers There's not been one great cord packer, so I designed my own cord packer. I get nothing for it. Pascal Dental sells it. I did come up with a catchy name. And in fact, if you're an educator, if you're in a university or you lecture, he will send you one of these for free. You want to ask for Steve Berman, okay? And trust me, once you try this, the design basically is so it'll get 360 degrees on every tooth in the mouth, so I don't have to have multiple cord packers. I don't have that little serrated end, which I hate because it pulls the cord out, especially if you're using a knitted cord, okay? All right. Steve did offer me 20%. That's normal business. I said, no, please, I won't. I can't take the money. I'm a capitalist like anybody out there, but I don't want you to buy something because I'm making money off of it. But I did say give it to the people. Give them the 20%. So you can go to Shine. They'll give you a discount. Another company called Pike Dental, they'll give you a discount. You can see the codes right there. If you're interested. All right, then here's the last thing that we do before we start our finalizing process. One of the things that I found doing this workflow is no matter how hard we tried up to that point, when Jed designed and machined something, and it's not him, okay, it's just, I can see it's the digital processes. There's always a little bit something, if I just go straight to machining, that I didn't like. Whatever. I mean, maybe it was the length a little bit, maybe it was the volume, was under or over volumed. So what I do today, because this is really the first machining for the patient that goes in the mouth, is before I go to the final, before I touch it up, or before we actually go to the final machining, the restorations, I actually have Jed machine from PMMA, or you can print if you want to, what the computer sees or what we designed. So this now goes in the mouth, because if we haven't really done something directly in the mouth from the machining, that what can happen is the machining can be a little off and you have to start over. You want your machining 98% close. If your machining's way off, you're adding porcelain, which defeats the purpose, or you're doing it again. So he machines, he sends me this, we try it in. Yes, it's an extra appointment, but it's a lot extra work to do it 2 and 3 or 4 times. This is an hour, hour and a half. We pop the temporary off. Hopefully I've been intra-enamels. We don't need to anesthetize somebody. We snap in or pop in the machining, what the machine sees, and then I just tweak this a little bit. Jed, this a little too big. Let's bring this in a little bit. Length's fine because she wants big teeth. Okay, great, no problem. And then from there, he now has a physical thing that he can see when he machines it. Okay, that is our workflow. That happens to be TelioCAD. Lots of good materials on the market. So let's talk about our materials that we're actually going to machine. I briefly touched on them at the beginning of this, and we could do layered. I mean, we got a technique for that. We can machine dies and layer. Machine glass ceramics, obviously, and zirconia, and I strongly lead toward machined ceramics. Because let me tell you, other than Emax, the best looking of the machinable materials is the high feldspathic materials. Okay, like Empress or like the Vita material. What I really like is the gradient blocks. This happens to be Empress Multi. It's a multi-layered block. It's completely monolithic, just finished with a couple little white spots and stuff on the surface. But I get a really nice gradient of color, and yeah, I do a little bit of interproximal color here. That looks as closest to feldspathic porcelain as you possibly can. And monolithic, I have just not seen a chipping problem. Yes, it's nowhere near the strength of an Emax, which roughly half the strength, but it's really double the strength, double the flexural strength, double the fracture toughness than a feldspathic porcelain. And wow, I mean, I think that looks 98% as good as anything humanly I could do, or I think most people could do with feldspathic porcelain. Okay. So that is probably the material of the choice, and Vita Trilux, okay, which is a great material too. All right, now again, you want a gradient block, but there's the other art form too, is how you sprue it and how you nest it in here. The bigger mistake I see people make is they'll nest the veneer way down here, and it doesn't look that great because you all have dentin color. So you want to be able to nest it in a certain way, and there's a certain process that we go through. And if you have any issues with that, again, reach out to Jed, and he can help you design that. That sprue design and how we sprue it. Sometimes we'll do 2 or 3 little sprues around there. All right, now I want to show you, they asked me to do a little video of some of the things I'm doing and how the workflow happens. So I got about a 5-minute video coming up here, really all the steps in the process. Let me show you this case. This I love this guy. Fascinating dual profession. He's an attorney and a chef. And what he likes to do is private chef, where he goes into homes, somebody hires him and he cooks dinners and things like that so that he doesn't have to have a restaurant, so he can do during his day job be an attorney. He had some old bonding here you can see, and this isn't all that old. And, bonding can be great, but I can tell you that plastic just, 3-5 years is usually what I'll see where it starts to break down. All right, so here we go. I got a couple faster clips and a little slower clips, but it's literally only 4 minutes. His teeth were over contoured. Now, it's wonderful if we get to do a purely additive case, but some cases are subtractive. So his teeth are over contoured from where I want to go. So my first step in the process, I got to take some of the composite off. He is not anesthetized. I'm pretty sure his composite is still mostly in enamel. So I'm just doing my initial setup, and I actually don't want him anesthetized when I do my aesthetic prototype because I want the lip to move normally. So I take off the bulk of composite so my matrix will seat. So I've made your standard matrix here. I've actually relined it with a little low viscosity PVS, and I'm putting my first thing in his mouth here. Now I would have preferred not to have to remove that composite. Most of the times they don't, but sometimes you do. Look how well that fits. I just got to flick off a couple of pieces. He's not anesthetized. I sit him up and he says, "Yeah, doc, but I want a little bigger teeth over here." All right, so I've got my wax up all ready to go. Now I typically don't like to see more than 2 patients in a day. I'll do one in the morning, one in the afternoon. I touch the wax up right away. I made a new matrix, and then we're popping this in the mouth. So that takes me 5-10 minutes to touch up the little small touch-ups, reline the matrix, and here we go. So the teeth are just a little bit longer, and I changed the incisal plane. Same thing, just pop off those little thin pieces. And he loved that, by the way. I forgot to add that in. Now we're ready to go. We can do this the same day or a different day, where we can start to work for his preparations. Now you all know this technique. It's been around forever, depth cutters. Now the only thing I would say that I might do different, I never use 3 depth cutters. One, they don't go to the depth, and number 2 is sometimes when I'm going left and right with 3 depth cutters, I do a papilloectomy. So I only use 2 depth cutters. Now I also make 2 or 3 passes. I find if I don't make 2 or 3 passes, I'm under reduced at the line angle. Then the technique you've all seen, take a pencil, I think that came from Mark Friedman. Take a pencil, mark it, and just remove the excess. And I'll take a little bit extra off at the incisal edge to get that extra room for translucency. Now, once I've done my depth cuts, you don't have to grind all the rest of the stuff off. You certainly could. I would just get a sickle scaler, a stiff sickle scaler, a small one but stiff, and I would scale off the pieces. Now, be careful, don't scale too hard. You don't want to break the tooth. Now I'm under a microscope. I have a microscope. I have a global microscope over here off to my left right here, and I like to finish with a microscope. I don't like to do gross reduction with a microscope because I end up doing something wrong. But I like finishing. So typically then I'm going to use, I use either an 8876, that's a small chamfer diamond that I can create the 3/4, or an 8878. And I love electric, so I'm going very slow with my electric handpiece here, putting my finish line on with 1 layer of cord, fairly standard techniques, doing my best to stay intra-enamel, just to speed up, just to show you. So I usually use individual pieces of cord for the first layer of cord, and then 1 long for the second layer of cord. All right, then I prep into this little L zone. I want to make sure that to use my Explorer, sorry about the speed of the video, so we can get done, just to make sure that I get to that interproximal space, because the biggest problem I've seen with veneers is little open spaces, okay? I think Frank Spear jokingly calls it, what does he call it, black hole disease or something like that. All right, then we're basically cleaning up the teeth here. No, actually what I'm doing is I'm sealing the dentin. I had a little bit of exposed dentin right there. I happen to like a universal for this because I can do it before, after, during the impression if I want to, especially since it's all digital. I'm putting a thin layer of that resin on, self-etching primer, cure it just where the dentin's exposed, and then put a layer of glycerin so we know if the air inhibited. So we're ready for our impression now, and I'm trying to get it all in one if I can. If I can't, I'll just come back and get another one. Fairly standard techniques at this point, and then we scan. And I like to scan, everything, the palate, everything, distal to second molar, so that I have a full cast to work on. So you're all familiar with that technique. Now, at that next, what we're going to do, let me stop the video for just a second because maybe this is a little fast right here. One of the interesting things about sealing dentin, if we've sealed dentin, we now have an active bonding surface, correct? Whether we do it before or after the impression. The downside of that, there's some wonderful things that we know from the literature, Pascal-Mondy, things like that. Decreased sensitivity during the temporary phase. The problem is if I'm going to put some bisacryl on there, or maybe even any kind of resin, a flowable, it could bond to it. I might not get the darn stuff off. So actually what I found works the best is I take a little bit of Vaseline. So I'm putting a little bit of Vaseline on the margin so it doesn't run. Okay, it does not run, and so if you get water, if you get glycerin, it'll go all over the place. And then I'm going to go and do the rest of the normal processes. So typically, what I do, so that's the sealed dentin, a little Vaseline for separator, a little microscopic amount, only where the stuff is. I spot etch in the middle third of the tooth, but I always spot etch at the incisal edge. Why? I find with thin veneers, if I don't bond a little bit at the incisal edge, what's going to happen in function? They're going to fracture the veneer. So you won't know if it's a occlusal problem or if it's truly your design is wrong, okay? Or bonding or something like that. All right, then normal techniques beyond that point. Now you want to notice how I'm holding the burr, albeit kind of fast. Let me backtrack that just a hair. I'm holding the burr in a way that it's not touching the facial surface. Why? I just need to finish the margin. If I go over the facial surface with the burr, I just destroyed all that beautiful anatomy that I molded. So this is a very fast process if your matrix fits well. You're just finishing the margin a little bit, polishing it, making sure that you can get floss between there. Okay, and then standard techniques. That's what's called. That's a leather polisher. It's the only one I found that's small like that. I get it from a company called VH Technologies. It fits in a contra angle. Okay, so that's the typical processes as a dentist. Then here is the before and after, completely 100% monolithic. Okay, I got a happy patient. You can see it was a little bit bigger than that first aesthetic prototype I did, which he wanted and I was okay with since it was monolithic, and obviously I have to control occlusion, protrusion, and all that stuff. Now let's move a little bit into materials here. Looks like I'm getting out to about an hour here. Sorry, Jonathan, but I wanted to be thorough here. If you want to break this up in 3 sessions, feel free to do it. One of the interesting things that I keep getting feedback over the years, why people have stopped using glass ceramics, or they've had issues, let's say, with any type of, they said that it's broken. They cement an Emax crown or something and it breaks. And that was always fascinating to me because, we've got these strengths that are reported 400, 500 megapascals. According to the ADA, 400 is enough for a crown. All right, so we're very interested in this, as a lot of people are, and this is going to be a published paper. It's an accepted IAD abstract. Is one of the things that people have not looked at over time. When we test our ceramics, yes, we want to know the theoretic strength, okay, perfectly as machine polished, but we're also interested in, as the end user, what is the functional strength? What is the real strength after machining or after etching or after sandblasting? So again, I bought my own Instron machine, and this toy was about $4,000 that I have. Got a $250,000 in that. If you want to drive in my Ferrari, come over sometime and we'll break some stuff. All right, so what we did was very interesting stuff here, okay? We actually got higher numbers than the manufacturers. Got 470, 480 for Emax, a little over 500 for Soprinity. That's about what they report. 457 for this new Amber Mill HT, which they won't tell me 100% what's in it, okay? I don't blame them. They don't want anybody to copy it. So that's exceptional strength. But that was the pure scientific, how you would publish something in the literature. We take a block, we section saw it on a very special section saw like you saw in this previous thing right here, this toy right over here, and then we polish it so smooth you can isochate on it. So it's perfectly made stuff. Here's what happens post-machined and cleaned up with only 1 bar of sandblasting, which most people use a little bit of sand. They blast the inside, even low pressure, even though it's not necessarily recommended to do on glass. The strength dropped down to 300 megapascals on all of them, basically. They're all basically the same after sandblasting. They lost about 40% of the strength. All right, well, that's typically what we're doing. We're sandblasting and we're etching. This is not enough strength for a crown according to the ADA anyway, and according to other bodies that talk about these things. Now imagine if you're at 300 megapascals, okay, it's much easier to fracture, and you're super thin. The whole idea of conservative dentistry is to be super thin, all right? Now here's what happens though. Forgot I had this slide here again, the old age setting in. So what we wanted to do though is look at it, says, well, what would happen if we put a thin layer of resin on that sandblasted surface? We did literature review before we did this with zirconia. Steve Rosenseal, very famous guy at The Ohio State, if I said that correctly, did a lot of work with ceramics over the years, especially 70s and 80s, and he had sort of, I guess, a classic paper where talked about sandblasting feldspathic porcelain or etching, and same drop-off in strength, started at a lower number, but if you put a thin layer of resin on there, if you etched it and put a thin layer of resin, the strength came back up, theory being that the resin filled in the little micro gaps, bridged a little stress, absorbed some stress. So we did the same thing. We put, once we etched it, we put an extremely thin layer of resin, 40 microns or less. We cured that, and we put that structure back in the Instron machine, and the strengths came back up to pretty much what the companies report, around 450 megapascals. So I think you can see where I'm going with this. The sandblasting or grinding, same thing we get if we ground on it, would be the main reason for the weakening. And then if we didn't adhere it to the tooth, then we end up with this fairly low strength that it's going to fail at much lower fatigue over time, let's say. So this is why we need to bond glass ceramics. I got a wonderful argument with my rant brother last night about that. Hey, we don't need zirconia. We only need Emax because we can do everything in Emax. Okay, up to bridges, let's say. But my point was that, well, what if we can't bond? What if we got a subgingival margin? Well, the what if. So we do need stronger materials in higher stress situations and in situations maybe of normal crowns if we can't bond. And there's many times that we can't bond. We got lower upper molars, we can't isolate, we can't get rubber dam clamps on, blah 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 blah. Okay, so yes, we need some options. So the end point of this is I bond everything. If I'm using a glass, I don't care if they tell me it's 1200 megapascals, I'm bonding it. And I've had an unbelievably low failure rate over the years. And I'm known for doing mostly only that, to tell you the truth. All right, we also looked at the translucency of some of these new materials. This is all coming out in paper format, abstract format as we speak. And so this might be part of your thought process too, right? If you have a higher translucent situation, actually the two most translucent, they're statistically the same, Amber Mill and Emax Cat HT. The high translucent versions of the materials were around 50%. To give you a perspective, if we measured dentin and enamel, and we made up some crude samples of this, of enamel cutting and dentin and get in our machine the best we could, hydrated dentin roughly 33% translucent in a 1 millimeter segment, and that enamel roughly 70%. And that was very hard to get a couple of specimens like that to do that. Now, be careful when you see a translucent study. Somebody will go, hey, our material, or they claim ours is 60% translucent, meaning 60% of the light goes through. Look at the thickness. If I take a 1 millimeter segment and it's 49% or 50% translucent, and I thin it to 0.5 millimeter, it's going to roughly double the translucency. Not double, but it's a significant increase. And that's some of the fallacy of how materials presented. It's not a lie, but it's misleading. And the scientists that I talk to, enough people in the academic space, and I've been a professor in 3 universities, that the true scientists, and I'm a pseudoscientist, but work with true scientists, anyone would tell you, especially a functional scientist, the thickness you should be testing is your standard thickness that you're using. Now, the standard thickness we use is typically 1 millimeter, right? Okay, for a crown, maybe for a veneer too, but it's nice to know that number, and certainly you can test other thicknesses. Okay, now that's a great place to stop, Jonathan. That was probably an hour and 10. Certainly you can break that up, and this will move into the second part. So after it comes out of the machine, what do we do next? How do we go from good to great? Okay, and I like to call that what the enamelizers, dental sculptor, dental painter would do, and that's the basic book I mentioned at the outset of the lecture. All right. Because this is what comes out of the machine. what we see on the top. And again, I told you I like to over design it just a little bit and then I can shape it. Now normally I wouldn't try it in like this. I would have tried in the machine prototype from a PMMA, but then a little bit of work, a little bit of contour, a little bit of paint, and you can see the final result. It looks very real, very believable. And now what I'm going to talk about now is how to create natural surface texture and why it's important, essential if we're doing monolithics. If we're layering, if we can create some three-dimensional color, different opacities, different chromas internally, it's maybe not so critical that we have a surface texture, because that creates the illusion of depth. But if we don't have the ability to texture, we don't put texture in, then it tends to look very fakeish, very glass-like. So I learned all this from natural teeth. I see very few people, when I was coming up, 40 years ago, okay, 30 years ago, that were teaching these concepts. So Willie Geller actually taught me, so you really want to learn what a tooth looks like and how to create it, get some extracted teeth and make some impressions. So that's what I did. I made lots of impressions of decent extracted teeth, made models to look at what the surface is, just to show you a couple of different versions, a side view, just to see that little subtle fraction, a light reflection. Now, one of the morals, what I'm going to talk about as we go through here, is surface reflectance, or luster. We call that luster, glaze, you might call it if we were going to glaze it. I want you to notice a natural tooth when you take the moisture off, not completely dehydrated, but it's a little bit dry on the surface. It has a matte finish. It's not highly reflective. It's reflective, but not glass-like reflective. What makes it glass-like reflective is the saliva on the surface. Well, people will say, well, Ed, no, what's the big deal? I just polish it or glaze it. It's super glazed. You put a little bit of saliva on it, it's going to be fine. How many times, think about this, you've had this experience, I am sure. You've looked at a case, you like the color maybe. You like the shape maybe. Maybe it's a patient you met. Maybe it's an article you read. Maybe it's a lecture that you saw. And you saw it, but you knew it was fake. Something was wrong. The surface just looked wrong to you. Universally probably opposite words, it's probably over-fired, over-glazed. Then when you add saliva on glass, it looks fake. Now let me prove that to you. I need to prove that to you, not just my opinion here. Look at this young lady. This is a case that I did the ceramics for a good friend of mine. So I was involved in the treatment planning, the preps and all that stuff, but mostly just making the teeth and trying them in and stuff like that. All right, so she won the voice. No, she was on The Voice. She did not win The Voice. As you look at those 10 teeth there, your first thought before I said anything, you probably were looking, well, those look kind of bright, on the bright side. Fairly bright, okay? Pretty monotone-ish, not a lot of chroma. You don't seem to see a lot of surface texture there. But I would hope that you would think, hey, it's believable. It's an aesthetic result. It's not a fake result. It's maybe a little supranormal, but not past the point. Let me show you the close-up. Here's the close-up of the 10 teeth. That's the exact same 10 teeth. Now, if I showed a patient this and they looked at this, the first thing they would say, this view, and I was trying to sell them a case, I go, well, Doc, what are these things down here, these white spots? What's this gray stuff here? What's this white line here? What's this roughness over here? All right, those things, if you do not put them in your teeth at this view, the things that you see at this view that you don't see at this view, the teeth will look fake at full facial view. Let me demonstrate in just a second here. This is the before. All right. Now let me show you from some things I found in literature or advertisements. How many times have you seen this? You could find a Facebook or an Instagram ad, or open up an article or an ad and you see something like this. The criteria for selection and success is what it says off to the right of an all-ceramic restoration. And if I showed this to a patient, they go, Doc, I want that. Give me that, okay? But they don't know what to ask for. They all say they want white teeth, but do they really want white teeth, okay? What they want is bright, beautiful, but believable. Let's back out and look at those teeth on the right. On the right, it's the same, but on the left, no. I think everybody knows that that's fake. And I know everybody's saying, well, my patients ask for that. Yes, they ask for that. I get it, but they don't know what to ask for. When you walk in and buy a top-line camera, if you're a beginner, you're just going to ask for something that takes a picture, but you're not going to understand all the nuances to get a great picture. They don't know the nuances to ask for to get a great, believable smile. More than half, 80% of what I do is redos. Somebody got some teeth, they don't like them now, maybe they liked them on day one. Yeah, they always like them on day one if it's bright, but all of a sudden they started to realize they were fake. They started to realize that people noticed that they were fake, and they said, no, Doc, I don't want that. I want bright teeth. I want white teeth, but I don't want people to know they're fake. And then that becomes our ability. We have to educate them that we have to do this. Okay, so I learned the hard way. If I'm selling to a new patient, if I show them this, do you like those teeth? I don't show them this. I got to talk them into understanding this, but I don't show them this. I show them this. Do you like that? Oh yeah, doc, do something like that for me, okay? So I will never show them images like this unless I really get to understand. Now let me show you just more. This is, if I showed a patient this, and I actually show patients this is in my presentation consultation. I show images like this. What do you think of that? They go, well, doc, I like the color. Do you like the color? I have some very probing questions. Do you like the color? Yeah, I love the color. But something looks wrong. Well, what's wrong? And then they don't maybe know. They say, well, it looks squarish, or it looks, kind of. And I said, well, would you say it kind of looks like one big teeth instead of looks like an investigative reporter? Yeah, it kind of looks like that. Does it look a little too squarish? Does it look? Yeah, okay. All right, then I show them this. Now, this is one of the cases on the internet. I'm not picking on any dentist, but look at the midline. Look at this. This is a beautiful woman that probably, had a couple of things done, but they're not obvious. Her facial aesthetics, whatever she had done, aren't obvious. I can't find it. Maybe a plastic surgeon could. But if she walks in a room with teeth like that and you're talking to her like that, you are going to know those are fake. And I don't believe that she really wanted that. You might go, nice smile, then we're all going to turn around. How many times have we met somebody that had some facial aesthetics? Maybe they had their lips. I lectured at the AACD in April. This girl's checking in next to me over here at the check-in desk, and I look over here, and her lips got there 5 minutes before she did. Her lips, literally, I never saw lips that big. And I'm sure all of her friends were wonderful people. They said, whatever her name is, oh God, those look great. And they turned around and do you see, they're talking to themselves, did you see what she did to herself? Because we're kind of afraid to hurt people. And I understand that. Clearly this is terrible. And 1% of people might want this or less. With a little bit of understanding of shape, a little bit of understanding of surface texture, could have made that an acceptable result. All right, let's get into the how-tos then. Hopefully I've gave you the justifications of what we're going to do next. I was taught in school, and probably you were too. There's 3 levels of, let's say, anatomy: primary anatomy, secondary, tertiary anatomy. I think there's 5. I think there's 4 levels of texture, and then there's 1 level of surface luster, surface polish, and then we could say surface color too. We could break it down to 6. Now, what about armamentarium? So we'll get into that. What about the armamentarium? I typically like medium grit burrs. These are the burrs that I use. I have usually 2 versions. I have the round end. You'll see some videos in a second. And I have the flat-ended burr, so I can create what I want. And certainly you can use a fine if you want to. I just find these are cut faster, and since I'm going to glaze and polish, this gives me what I want. Now, if I want a fine burr, what I found is that a lot of the shapes that I would like that are fine burrs in the laboratory, they don't sell. So I came up with an idea, and it's an adaptation of other people's ideas, put it that way. I did not like any of the burr converters that were on the market. In other words, to take a high-speed burr, put it in a burr converter, and put it in a slow speed. So I had Brasseler make this for me. You can get this from Brasseler. I get nothing for it. You want to reach out to Justin Frigo or Larry Rose from Brasseler and say, hey, what was that burr converter that Ed came up? I don't even know the part number, to tell you the truth. Okay, so I can use any high-speed burr, put it in the burr converter, and put it in a slow speed. And that's basically what you're going to see me doing. Now, let's talk about how to do it. I'm going to get into the how-to right now. One of the things that I found, I know a lot of people like taking pencils and blues and reds and pencil marks. The problem is that clouds my perception of what I see on the surface. Does it theoretically work? Yeah, but I have a better way to do it. Think about surface texture. It creates reflections. I want to see the reflection. Really simple. I just get a light that I get below my eyes, and I move the object of my work in and out of the shadows, and I can see the surface texture then. Those of you that are dentists, which I assume most of you, many of you are doing bonding out there. Real simple. Turn your overhead lights off in your room. Get your chair light, move the chair light back and forth over the patient so you can see the shadows. So that's how I work. All right, now we're going to start at level 3, and here's why. Just basically due to time. I'm going to assume most of you out there know level 1, the basic shape of the tooth. You know, length, width, all of that stuff. Most of you know about line angles, so we'll touch a little bit on that. But what I see most people don't really understand is how to create the texture, the ridges, the valleys, the polish. All right, so after you machine, the interesting thing about machining, what happens when you're machining is creates a little bit of roughness, right? Because typically it's a medium grit diamond, so you got a little bit of scratches on the surface. I do not want to put my surface texture in scratches, so I'm going to need to get rid of the scratches. Premier Dental makes these things called fiber polishing disc. They're an impregnated disc specifically for getting rid of scratches. Okay, and it will contour if you go too fast. So typically what I do, about 8 or 10,000 RPMs with one of those discs, after I've got my basic shape of the tooth. And yeah, the computer is going to give you most of the basic shape and most of the line angles, okay? So you shouldn't have to hopefully touch that up too much. Now what I'm going to do, all I'm going to do is I took off the sprue, a little bit of contouring on the facial, and I'm going to take off those scratches. Then from there, I'm going to start on the anatomy. This slide was supposed to come before, but you'll get the idea. One of the things about veneers, veneers are a challenge to hold on to the die and finish on the margins. A lot of techniques have come along to hold a veneer or a crown on a die while you're working on it. Excuse me, my nose itching. They all work, but they all have their problems. I found the best way, for me, the best way is I use a little clear impression material. So polyvinyl siloxane, it could be silicone too. There's a couple clear silicones out there. I mix up just a little bit. I typically don't use the whole gun because that wastes a little bit. I put a little dollop on the inside of the veneer, not on the die. Okay, or you can put it on the die, but I typically just put it on the inside of the veneer. Okay, you seat it and just let it set and remove the excess. And I've never had a problem getting it off of the die doing this. Now I don't completely fill it up so it's everywhere, but some comes out of the margins. You just want to make sure it's seated all the way. And if it pops off, you just do it again. That's how I hold it on. All right, so let's move. So we've got that basic level 1 and level 2, which I don't have time, and I think most people seem to get right. So let's start with an understanding of really what texture should be there. This is one of the smoothest teeth I ever saw. But when I cleaned it, got the biofilm off, the stain off, look at that texture. I'm going to do that one more time, okay? Play that one more time. I've got this specialized technique where I created a little device to roll some teeth through there for video. I'm rolling the tooth through the video, and you can see that little subtle change in contour, the surface texture. Now that wasn't much. All right, let's look at a canine. Canine tends to have the most surface texture. And as you see that rotate through here, you see the hills and the valleys. You can see how everything sort of blends together. So let me share you how to do that. Share with you how to do that. Okay, and by the way, I'm in my lab today, and it's late at night, so sorry if I'm losing a little cognition here. Just a thought process here. I've looked at a lot of teeth. This is not 100%, but this is a general pattern that teeth follow. Whatever you decide to put in the central incisor, and I'm going to tell you what I put in the central incisor in a second, I put a little less texture in the lateral and a little bit more in the canine. A little more in the canine, because that's the general pattern I see. Now, we too often, I was looking around in outside in nature and man-made areas for a visual to describe what I see. Typically, most of the grooves, and my grooves were very characteristic of this. They look very man-made, and the best architecture I could relate it to is a storm drain. You've all seen storm drains. There's river jetties, different names, things that go from wherever water is up high down to the ocean or down to the lake or something like that. And they pretty much have the same contour on both sides of the hill. In the depth of valley, yeah, they might wind a little bit. And too often we do that. And when you start the texture, it always looks like that. In nature, the best thing that I've seen in nature that comes really close to describing what I see in a tooth is erosion on a hillside. Wherever there's been water or maybe snow that melts that comes down and creates a little bit of subtle change in surface texture. I want you to see how everything blends together. There's subtle little grooves within grooves. And again, I'll show you how to do this. This would be the central incisor on the right. Very subtle surface surface texture, could be more, and this would be the canine that I showed you on the left. Just to get into the general pattern, I've looked at so many teeth and I've measured so many teeth and photographed so many teeth, and yes, we can see infinite patterns, but we got to systematize it a little bit, especially if we're doing multiple teeth. So what I'm going to tell you next and show you next is I do more or less of this. I just do a little bit more if I want a more texturized tooth of this pattern, or I do a little bit less texturized tooth if I want less texture of the same pattern. And here's the pattern, and I've seen this in, I would say more than 50% of the teeth, you see a very similar pattern. Let's take the central incisor, let's bisect it. I photographed it from the side so you can see the texture better, okay, and lighted it from the side. So we bisect it. The mesial developmental groove bisects the mesial half of the tooth. So we take this, bisect it, we put that right in the middle. This goes up into and disappears in the gingival third. Very standard. It's deeper in the incisal than the distal developmental groove, and it's about 50% narrower. So whatever the width of this groove I make this one 50% bigger. And notice the edges of the grooves, the ridges, the sides of the hill, the erosions, there's no straight lines. There's no straight lines in nature. Don't make any. Don't make any straight lines. There should be a subtle change in contour. Not a random distortion or random fracture, but a subtle change in contour. All right, so that's the mesial groove. The distal groove does not bisect the distal half of the tooth. It is shifted toward the mesial. It almost starts on the midline. It almost starts on the midline. It goes up to, yes, the distal marginal ridge here. All right? That's a very common pattern. It is less deep, about 50% shallower than the mesial developmental groove. It stops just at the junction of the gingival and middle third. All right, great, I know that now. All right, so when I'm designing that, I follow all of those parameters. The other thing that I see, usually there's one supplemental groove, a secondary groove, which means there's small secondary ridges in the mesial developmental groove. Usually there is two supplemental grooves in the distal developmental groove. Usually there's a horizontal groove. If it's a really big tooth, I'll make it more prominent. If it's a smaller tooth, I'm going to make it just very, very subtle, maybe not at all on the horizontal groove. And then I want you to notice here, look at the pericomata. Usually you will still see pericomata, the little teeny tiny horizontal grooves, lines of rhesus, at the depths of the grooves only. Usually it's gone on the ridges because of toothbrush. The ridges are also more reflective. They are more polished. They are more shiny than the depths of the grooves. The depths of the grooves are a little more matte. All right, so we're going to talk about how to create that. So look at this here. You've got 4 examples, more or less of the same thing. If you look for those patterns, you will see those patterns. You'll see a lot more here, okay? Maybe a little less here, a lot more surface texture here, but that general pattern that I just described. Okay, so let's do it. We've got our basic shape. We've got our line angles where they're supposed to do. It's just really easier for me to draw here. Okay, I'm going to draw the initial grooves here, so I put them in the right place. Now the micro texture we're going to use with a light like we talked about. All right, so typically what I'll do is I'll mark the midline, and I'm going to draw a pencil line to divide the tooth in half. Okay, then I'm going to draw the mesial developmental groove that bisects the mesial half of the tooth. The distal developmental groove starts on the midline, 50% wider. Okay, then I draw the supplemental grooves. That's where I'm going to start them. All right, now the lateral has one developmental groove. It's a very small developmental groove, almost notch-like. Again, due to time, I can only show so much. There is a small supplemental groove in the mesial lobe. By definition, it's a supplemental groove, and a wider supplemental groove in the distal lobe, almost mirroring the central, except for that little notchy developmental groove. All right, the canine usually has 2 large developmental grooves, one on the mesial, one on the distal. They usually stop in the middle and gingival third junction, and then I'm just drawing in a little bit of horizontal groove that I want to put in. Okay, so that's how I'm going to do it. All right, now here's the basic way that I do it. I found a systemized way that I can explain it and do it and get the look that I'm looking for. What I found is that if I use 2 burrs, different sizes, with 3 movements on a groove and 2 movements on a ridge. So it's 3 movements on a groove, 2 movements on a ridge, which I'm going to show video, and it's 2 sizes of burrs. So if I do that, I get something very natural. So let's talk about the movements first. The main movement for the groove is going to be the main direction of the groove if I'm going incisal gingival. Okay? So main direction of the groove. Now, these two things are combined. That second movement in the groove and the first movement of the ridge, so create that movement, the connection between, the ridge and the groove, is I take the burr 90 degrees to the direction of the groove and I go from the top to the bottom at a quarter round movement. Again, video coming. Burr 180 degrees from the top of the ridge to the depth of the groove on the other side. Okay? Now, the ridge has 2 movements. We got one movement going down to the depth of the groove. We need the second movement of the ridge going toward the either the center of the tooth or in the proximal region, in this case, to define the ridge. And again, a quarter round movement. So let's take a look at that. You can use fine burrs. You can use medium grit burrs. I tend to like these burr converters for medium or fine burrs, like I said. So let's go ahead and drop a burr in the burr converter here. All right. We're going to go into a slow speed handpiece. I'm typically going with glass ceramics about as fast as it would go. Okay, so 30, 40,000 RPMs for my micromotor there. All right, the main movement incisal gingivally, like you saw. Now, I've turned it 90 degrees. I'm going from the top of the ridge to the depth of the groove in a quarter round movement. I go to the other side of the ridge, the other side of the groove, or the other ridge, other side of the groove, quarter round movement, top of the ridge, depth of the groove. Now those subtle little vertical movements incisal gingivally, that was to create these supplemental grooves, the subtle changes in contour vertically. All right, same thing on the distal groove. Now you can work from 2 directions. You can work the quarter round coming incisally, or you can work the quarter round coming gingivally. So I'm taking 2 different directions, which gives me a little bit better 3-dimensional anatomy, a little bit better blending. And notice that I'm subtly bouncing. I'm not having a very even movement. So kind of like you're playing the drums, lightly tapping. You want to have a little subtle movement as you're moving so you don't cut straight lines. So you don't cut perfect curvatures. You don't see them in teeth. Again, the vertical movement incisal gingival was to create the very subtle supplemental grooves. Okay, that's burr 1. Now burr 2, like I said, there's 2 burrs, 3 movements, and to a groove, 2 movements to a ridge. I usually use a needlepoint burr that I've cut the tip off, or some of them you can buy with tips cut off, and I'm going to make the exact same movements. Main direction of the groove, incisal gingivally, 90 degrees to the main direction of the groove from the top of the ridge to the depth of the groove, 180 degrees, the other ridge from the top of the ridge to the depth of the groove. So here we go. Okay, this is a needlepoint burr, medium-sized needlepoint that I just cut the tip off. So I'm making the same movements with a little bit smaller burr. Incisal gingivally, main direction of the groove, top of the ridge, depth of the groove. The other side, top of the ridge, depth of the groove. Okay? Now, I realize many dentists, you probably aren't going to do this, but CEREC dentists, you might want to consider this. Sometimes you're shaping temporaries. I do the same thing with a temporary, obviously with a carbide burr. But so your technician understands this, please feel free to share this with them, okay? I'd be happy, Jonathan, to give you a PDF of every image here. Same movements, okay? Now, yeah, you're going to maybe get a little diamond, little carbide burr mark from the top of the burr when I cut the top off. Great, I'll just cut that off. I'll just finish that off or rubber wheel it off with something on the end. Now, I've came from a gingival direction and also incisal direction. So the last thing I do is put in the pericomata. How do I put in the pericomata? With a needle point carbide. Those little teeny tiny horizontal lines, and those are done at the depth of the groove only. Now, interesting question out there for you. How many of you know what roughly would be the average of pericomata in a central incisor? I've counted them on several central incisor, and I read an article published, can't remember the author, bad about remembering names sometimes, somewhere between 140 to 160 pericomata in a central incisor. I don't think you need to do that much. Typically I count 100 to 120. I've counted probably 20 or 30 teeth over the years, so typically I'll make 100 passes. Yes, it takes a little time, but I want surface reflection similar to a natural tooth. I mean, I'm in the aesthetic business. People come to me because they want teeth to look good but believable. All right, now here's the last thing I do. What I found with these harder ceramics that I don't glaze normally, that's going to roll like porcelain, is that sometimes my surface texture is a little edgy, it's a little rough. Super simple. I learned this from some artists that draw, okay, how they blend edges. So I call it blend surface. They'll use a little edge of an eraser or maybe a little edge of charcoal to go left, right, up, down. So they drew an apple, the tabletop, a bottle, or something like that. It looks a little edgy, okay, a little artificial. So they'll take a eraser and just microscopically go around the edges of their pencil lines. So I'm just doing the same thing with a burr. So this is at about 10,000 RPMs. I use a bullet-shaped burr. Noritake just stopped making this. Bummer. It's a DP-SO2, so it doesn't matter what the number is. So Brasseler's now making this for me. You can get this from Brasseler. Okay, sort of a bullet-shaped burr. Again, I'm taking nothing for it, okay? So all I was doing, left, right, up, down, left, right, up, down, just to kind of smooth the surface, knock off the sharp edges. All right, just let's touch on this one more time. I showed you that with real fast. I want to talk about this again in just a second. It would be rare to still see the pericromata on the ridge of a tooth. Usually you see it in the depths of the groove. Now the thing about the pericromata is if you're going to do them, do it right. Bad looking pericromata looks terrible. So remember, 100 passes typically at the depths of the grooves, and they don't overcross. They don't cross over each other. So you got to use some sort of magnification and go left and right. So single tooth I made here, 3-unit bridge here, and then a little bit of saliva on here, yes, but these little subtle, teeny tiny, microscopic horizontal lines like the natural tooth there gives that dispersion, diffusion of light that's much more natural. This is the natural tooth here. Okay, so again, here's how to do it. I just separate out the little video again so you can see it. This happens to be a high speed. I'm actually doing it in a high speed, a straight nose cone, high speed, air driven high speed, and just going left, right, up, down. I mean left, right, left, right, left, right, left, right, left, right to 100 times. And then if I want to put a vertical crack in, I do the same thing with it. Now, I don't have time to do all the stuff in zirconia. I have a whole lecture on zirconia, John. I'd be happy to do that at some point in time for you. But I would like to say about pericromata, because this is really misunderstood. Do not use a burr if you're doing pericromata. Do not on zirconia, or unsintered zirconia anyway, because it'll just destroy the surface. It'll never look right. Use what's called a glass etcher. You can buy this on Amazon, plug in glass etcher or Alibaba or anything. It's about $7 or $8, and just make 100 passes left, right, and a little wavy line like that. If I'm going to do it, and if I'm trying to copy maybe a single central, and this was a single central case. All right, so that's basically how you do it. And I don't do it on the tops of the ridges, like I said. All right, monolithic zirconia, no porcelain, no color. All the color was in the pre-sintered stage. The zirconia internal colors, surface texture, and polish. No glaze. Now, do I glaze? Yeah, sure, but that's a different topic, and how I do it and how I polish it. Just to show you that you can get a monolithic zirconia surface reflectance very similar to a natural tooth. All right, now the last topic I'd like to get into, I can't get too heavy into this because I was asked to keep this whole thing in an hour and a half, and I think I'm about an hour and 40 minutes, and again, I'd be happy to link some videos on my website if you're interested, okay? But we do have to create that differential surface luster. So natural tooth. So here he is before. Yeah, we don't like the shape of the teeth. I'm going to do a little crown lengthening on her, and that's how I got some of the length on her. You saw this case before, but look at that differential surface luster. It's a little more polished on the line angle. It's a little duller in the depth, and how you get that is polishing processes, okay? And again, I really apologize due to time limit. I can't get into this, but I want to show you this case all the way through. Here's after the initial crown lengthening. I was able to do it with a laser because we had plenty of dental gingival complex. Her bone was in the right spot, blah, blah, blah. All the things were taught. All right, but look at, here's the tooth where we're just, this is about half millimeter incisal to the CEJ. You can see all that differential, beautiful surface texture, okay? Here it is after the prototype that I made. Here is the try-in of my initial design from a PMMA that we machined, and she said, "Doc, those teeth look a little too big to me," and I kind of agreed. So I just kind of visually narrowed them a little bit by bringing in the line angle there. I brought the line angle a little bit. I stayed with that leg length to get this finish here. And again, this was done with a differential polish, so I tend to polish the line angles a little bit more. I leave the I dull a little bit the depths of the grooves. I use actually a feather light from Brasseler, the pink, and that's how I do it. And then the surface texture you all saw. And there's very little color on the surface. The only real color on the surface is a little bit of blue at the line angles, and I simulated some mamelon effects. But when we stand back and look at the full face here, it looks very believable. In fact, it almost looks a little fakish. It can, okay? So beautiful, beautiful young girl, and she just did not express herself. She changed. I mean, this is the fun part of aesthetic dentistry, right? We've all seen this. Some of our patients are nuts. I get it. No matter what we do, they're not happy, okay? But people like this, that it just changes their personality. She becomes a different person. And fun photography. She has all of her clothes on, okay? God, my wife hates it when I do this. All right. Well, thanks everybody. Jonathan, apologize for going a little bit over, and I'm happy to give you a couple of videos on staining that you can pass on to people, or how I do surface color, because I wasn't able to get to that. Thank you, everybody. Hopefully this is useful to you.